All right, so we've talked a whole lot about Stacy. We've talked a whole lot about quadratics and looking at them and finding zeros and things like that, but now we're going to kind of expand this to talk about polynomials, okay? So, first, I guess we need to say, what is a polynomial? And we've talked about this before too. What does it mean to be a polynomial? There are two rules I told you before. What are they? One or more terms. What else? It's something about the exponents. Huh? They have to be what? Well, the standard form. Nobody remembers? No. Let me just tell you. The exponents that are hooked to the variables, those are the ones I'm talking about, must be positive whole numbers. Do y'all remember doing that? And I put up some up here that were like x to the square root of 2 or something. Am I getting confused? I know we did that in here, didn't we? Did we not? I think we did too. Thank you. I think we did too. Okay. So that's what it means to be a polynomial. They can be as small or as big as we choose, but it's still a polynomial. Okay, it's kind of like that little, remember when you learned about squares? Every square is a rectangle, but not every rectangle is a square. Okay. Every quadratic is a polynomial, but not every polynomial is a quadratic, and so on and so forth. So we're going to talk about some different types of polynomials. Before we do, let's talk about some parts of the polynomial equation. And I think I'll do that by just showing you an example. Is that a polynomial? Yes. Because every exponent hooked to the variable is a positive whole number, yes? Okay. When it is in standard form, and I think this is what Catherine was saying earlier, standard form is always whenever you order it by the exponents, descending order, okay? I'm going to put descending order. That's what it says of exponents.
Yo, we can't listen.
All right. So there's a couple of very, very important pieces. Not that everything's not important in a polynomial, but a couple of really important pieces. The first is this number right here in the front. Does anybody know what that's called? The leading coefficient. It's called the leading coefficient because when it's put in standard form, it leads the equation, okay? Now, if this were not in standard form, you would have to go through and find the highest exponent in order to find the leading coefficient. So be very careful of that, okay? It's always hooked to the highest exponent. I'll put that in parentheses. Highest exponents coefficient. And then there is that highest exponent. Does anyone know what that is called? You might not know this. No. Good guess, though. It's called the degree of the polynomial. And we'll do a lot with the degree, okay? So degree is always your biggest exponent. One other thing, the number on the end without a variable, bless you. What's that called? Constant. Tell me, based on your knowledge of quadratics in that whole chapter we did, what also is the constant? The y-intercept. Absolutely. Because if I plugged in a 0 for every x there, then I would get the only thing left would be the 3 there, which is the y-intercept. So we're going to be doing a lot of graphing, a lot of classifying. By the time we're done with everything, you will have, I think it's I think everything with domain, range, everything ends up being 8 or 9 pieces of analysis you'll do for each equation. Okay. So I'm going to teach you a couple of those steps today, and we'll finish the rest on Monday. The first one, I'm sorry, tell me when you're done. Oh my goodness, because why would we ever learn something in math, right? Well, you already know domain and range, that's 1, 2. Then the sketch of the graph is another one. You should be able to do that. And I'm fixing what I'm going to show you in just a second is really easy. You could pick out the degree and the leading coefficient and the constant, right? It might be 10 steps. As I start going over them in my head. All right. First thing we're going to do is we're going to classify our polynomial. Classification of polynomials. Classification of polynomials is based on their degree, and the degree is the biggest exponent, right? I think you'll find as we go through this, you know most of these. And the name. If you have a degree of 0, think about this for just a minute. You have something like y equals 5x to the 0 power. What do you have? Anything to the 0 power is what? 1. So if you've got 5x to the 0, what do you have? Y equals 5. Y equals 5. That 5 is called a what? Okay, what else? If there's no variable hooked to it, what's it called? Constant. A constant. So we call any degree of 0 a constant. Okay? If we up this degree to 1, so now I might have something like y equals 5x plus 2. What type of polynomial do you think that might be? Look at the equation. You've done this since probably 7th or 8th grade. 5x plus 2. What kind of equation is that?
Oh, I know this.
Y'all are overthinking it.
I know this. What?
Which is a mx plus b graph a line. That's right. So this is a linear equation. What are y'all arguing about? 5 is the slope of the line.
You said the whole thing. That's the slope of crazy.
Y'all better get this one. Yes. Good job. Thank you. Catherine got it. That's a quadratic equation. If the highest exponent is a 2, we have a quadratic. Now the next ones you probably do not know. If you have a degree of 3, does anybody know what you call that? Cubic. You're absolutely right. A cubic. And I should probably draw you a little picture over here of what these are going to look like. Constant. Oh, I need to. Linear. They can look either way. Quadratic, you should know what that looks like. But as we start adding on degrees, guys, and this is very important, as we start adding on degrees, I want you to look at how the graph changes. Look at from constant, linear, quadratic. When we get to cubic, the graph's going to look something like this. Look at the difference there. What's happening? I'm adding another, kind of another hump, another vertex type thing, another parabola looking piece. So, same kind of concept whenever I go to a degree of 4. I've used all my colors. We call this a quartic. And this time, it may look something like this. Now, these humps can start getting stretched out, squeezed in, one deeper than the other, but in general, okay, that's what it's going to look like. I won't make you memorize up past 4, which is a quartic. Quartic. What's ugly? Oh my goodness. Oh my goodness.
I've never seen that in my life.
All right, so questions so far. All right, other than classifying by the type, I want to talk to you for just a second. What time is it? So definitely, we're going to play around with the calculators in just a second.
What time is it?
Your homework, you're going to classify, and you're going to make sure that you can graph in a suitable window. And I think I'll save in behavior for Monday because it's getting late. So I want us to practice graphing these and making sure that you can see the entire graph on your calculator, okay? Which means we're going to have to manipulate the window some. So let's take out your calculators. Two x to the 4th minus 5x cubed. Actually, I want to make sure this comes out like a pretty picture. Oh, never mind. Let's do this one. Apologies.
My pencil is busted.
X to the 4th minus x cubed minus 4x squared plus 4. Before we graph it, tell me, is it a polynomial?
Yes.
Yes, it is a polynomial. I could change this, and I probably should change it to f of x because it is a function. What is the leading coefficient? 1. What's the y-intercept?
4.
What's the degree?
4.
What's the type?
Don't know.
Quartic.
Yeah.
Quartic.
Yeah.
All right. So this is where it starts getting sticky. I want us to graph this on our calculators.
What is your graphing calculator?
You get a graphing calculator.
Can I get yours?
Can you get mine?
Yeah. The one I used up there.
You give me that one.
Where that, Miss McGee?
The website is fine for right now, but here's the problem. You can't use your tablet for a test. And you definitely don't want to wait until the day before the test to get a calculator and then not know how to work it because they get sticky.
Can I use yours?
Yes, I think it's, Jason, is that calculator back there?
Can I use it on the test too? Because I don't got no money to be buying no calculator. I really don't. Oh, then I lost it.
Okay,
I need it.
take out your calculator. I told y'all I'd have it by today.
So I just use yours. Yay.
All right. Hit the button that says y equals. We're right up here at the top. Does everybody see where I am? Can you see my? I wish I could change my cursor to be a little bigger. Y equals. Oh, come turn it on.
Oh.
Oh my goodness, what is going on? There it goes. All right, y equals.
It's not right there on here. How do that, Miss McGee? What y equals?
Get the other calculator, show me.
Jesse, you gave me the wrong one.
Golly.
See, I thought you was Tyreek Hill. He don't do that. This graphic calculator.
Y'all see your y equals? Mine crashed or something. I got to open it back up.
Miss McGee, what the other one at? This is the only one you got, ain't it?
Yeah, this is yours. That's the one that's on the desk.
I just used one yesterday. It's a little faded.
Oh my goodness, my program's not working.
It's like graphic.
There we go. All right.
Here you go.
Y equals, and you should get a screen that looks like this.
Oh, this is not work. Get another.
Are we all here?
Yes.
Casios, you need to go into, hit the button that says menu, and then graph.
So y equals what up?
Yep. Clear out whatever's there, so you wouldn't.
Yeah.
Okay. All right. You can't see that?
Behind.
Oh, behind the calculator. All right, so I'm going to input this function in y equals, okay? So when you do this, there's a little button here. Can y'all see where my cursor is? That's your variable button. Pushing that is,
Oh my god.
pushing that is going to pull up your variable x, okay?
You talking about XT?
So you want, you want x, and you want to raise it. This little button here is your caret that raises it to another power. So you want to raise it to the 4th power minus x again to the 3rd power.
Rise to the 3rd.
This might be easier if I like get the Promethean pen so y'all can see where I'm clicking. Minus x to the 3rd minus 4x.
4.
And there's a little squared button here. You can use that, or you can raise it to the power again like we did.
4x squared?
Yep. Plus 4. So everybody with me? Okay. What I want you to start with is I want you to start with a normal window. Now when we push this, what's going to happen is it's going to give you a 10 by 10 window. Okay? And I want you to really understand what that is that's happening. If you hit zoom, see the zoom button?
Click zoom.
Zoom 6.
Click 6.
Yep. So this is a pretty good window for me. Do you agree? I can see the humps in the graph. It's a 4th power, and I do see all those. What does that say? Did you do zoom 6? Your plots are wrong. All right. If you don't like that grid on there, I can take it off for you just on that. All right. Let's say, all right, did you hear what I said? A standard window is 10 by 10. So it goes negative 10, 10, positive 10, negative 10. Yes? Let's say I want to zoom in on this a little bit, and I want to adjust my window. And I know there's a zoom button on your calculator, but with everything we're going to have to do, I really want you comfortable adjusting the window ranges, okay? Let's say I want to cut in and I want to see maybe this much of the graph.
Hit zoom.
Okay? I don't want to do zoom. I want to adjust my window so it's exactly what I want to see. Because sometimes you might need to see just a little bit up, but you don't want to see anything else. So I'm going to look. I want this is my x-axis, yes?
I think.
And my y-axis. You think? All right. I'm going to take my x out to, what do you think that is? About what? 5, maybe 5. Remember, we go all the way, this is up to 10, so that's probably about halfway. Would you agree? So maybe negative 5 to 5 on my x's. And then on my y's, I look like I might be going up a little bit higher. So maybe, let's say x is going negative 5 to 5, and y is going what? Negative 5 to what? Come on, guys, you're going to have to be able to do this. I need you to think with me. I feel like I have the attention of about a quarter of you. You will not be able to do the graphical analysis if you cannot work around your calculator, okay? And this is different than the other technology you have used. I am going to adjust this window from about negative 5. I'm going to go up to maybe 7. Hit the button that says window. You see an X-min and an X-max. That is adjusting your X-axis, okay? So remember I said I wanted my X to go from negative 5 to 5? I'm going to adjust from negative 5 to 5.
Just type in negative 5.
Oh, thank you. Yep. Now, The scale that's there, that simply tells you how often you want a tick mark. It's saying if the scale is 1, then every 1 unit it'll put a tick mark. What did I want my y to go from? -5 to what?
7.
To 7, -5
-5.
to 7. And I'm just going to hit graph from there.
What graph that? Oh.
That's a much better picture in my opinion. Looks a little better.
It's just bigger, that's it. It's just bigger, Miss McGee.
Well, it's zoomed in. Now, instead of this being 10, this is 5. And instead of this being -10, it's -5. So it's kind of like whenever you adjust the numbers on your graph, it's the same thing. Yes? Do you have a question, Linda?
Mine's not.
What do you get? You're fine.
5 to 7 has to be negative.
Anytime these are highlighted up here, just go. Yeah.
Did you use 26 O's?
Yes, that's it.
Yeah, did you use 26 O's?
No, you don't have to on the calculator.
One real thing to do is when you write 4 parentheses, you go out of the first set, so then multiply it by your
Is that?
It might be automatically.
What she thought I said? What-
Yeah,
what I
who
said?
said Miss McGee? Yeah.
Just right.
Yes. So whenever you hit enter, it says draw right there. You hit draw. Alright. On your homework tonight, here's what you're going to be doing. You are going to be getting the picture to come on your calculator. Okay, and then you're going to sketch for me on your homework what the picture looks like and tell me what the dimensions of the window you use were.
Right.
Because that's why I said pay attention. I want to make sure that you can adjust the window to see the graph. Okay? If you can't do that, you can't do the rest of the analysis we're doing because Monday we're going to be calculating all these critical values. And if you can't see all the critical values, you can't calculate all the critical values.
So what that mean?
Huh?
So what that mean?
That, what do you mean?
That mean you fried.
You fried. What'd you say yesterday, Tanner? Not fried, it was what? Scorched. All right. So I want you playing around with your calculator and really getting used to graphing on it, okay? So for your homework, and pay special attention.
We put it all in now like in class too.
I'm going to let you start because you got about 10 minutes before class is over. Definitely start now so I can help you if you need help. Let me get out of this.